Welcome to a short lecture on list basics in Scala for an introduction to the art of programming using Scala. If you haven't yet seen the short lecture on arrays, or if you're unfamiliar with arrays, you should probably watch that lecture first. So, lists are in many ways similar to arrays in that they are both sequences. They're collections that keep their elements ordered one after the other, and just like we could make a list by, or just like we could make an array by saying array and following it with the values that we wanted, we can do the same thing for a list. You can also give these names, so nums equals 2.3, 7.8, 3.14159, 5, and you can index them. There we go. You can index them as you did with arrays. They are 0 indexed. This turns out to not be the standard way that you will get elements out of lists, because it is slower to get elements that have a large index out of a list this way, but the basics are the same. However, you cannot assign values into lists. Lists are immutable. So we said that arrays were mutable, meaning that you could write values into the elements of the array, change the values of elements. For a list you cannot. Okay, once a list is created, it is always exactly the way it was when it was created. There's nothing that you can do to it. So this nums, which val nums, is always going to be exactly the same thing. Now, while that might seem like it's not very useful, it turns out that fact is offset by the fact that there is a way to efficiently and easily add things on to lists. So, in this expression here, this colon colon is an operator that we read as cons. It's doing a construction. And as you can see when we execute this, just to make the types more consistent, this takes the value that we put before the cons operator and conses it, adds it onto the front of our list. You can also do this with so in theory I could say 1 cons 2 cons list of 3 4 5, and I get 1 2 3 4 5. If I only wanted the list 1 2 3, I can't do that. That doesn't make sense in Scala because nothing in there was a list. Because you are often, when you build up a list, you're often starting with something that is empty and consing onto the front of it, there is a simple name for an empty list, and that is called nil. So nil is a list that doesn't have anything inside of it. And as you can see here, this 1 cons 2 cons 3 consed on to nil gives us the list 1 2 3. Now, I mentioned earlier that the way that you run through lists is not typically with direct indexing. And we typically don't do that. Actually, it's worth noting that even though I did this cons operation, the original list is the same. There's nothing that I can do to change nums at this point. I can make longer lists, but they will be different lists. Not the first one is set in stone at this point. Instead of using indexing, the typical way that you pull off elements from lists is to use two different methods. One is called head, and the other is called tail. And as you can hopefully see from this, head gives you the first element of the list, and tail gives you a list that contains everything after the first element. These are efficient operations on a list, and we can use them to write functions that run through lists and do things with them. So to illustrate this, we'll switch over and work on a script. Once again, we have some comments in here that will help us to break things up. And we'll start writing something that is very similar to what we wrote for an array. It's worth noting the fact that with an array, we could build a large array that was full of default values using the syntax new array of whatever type we wanted and whatever length we wanted. You can't do that with a list. And the reason is because that would be a very pointless thing to do with a list. Because the list itself is immutable, filling a big list of default values is just a waste of memory. You only want to put things in a list when they have values that you are interested in. So we're going to work a little bit differently when we read in values and stick them inside of a list. So if we write a method called readList, and here, as it says in the comment, this time I want to read something and I want to specify the length. So we will pass in how many elements we want to read, and this is going to give back to us a list of, because we did it before and because they're easy to type in, integers. And the way this works, we're going to write this recursively, so as always, we need a base case. If len is less than 1, in other words, normally that will be 0. In theory, you could call this with a negative number, and at least we want it to not crash. If you ask for fewer than 1 elements, the list has nothing inside of it. So we want an empty list. And we'll use the name nil for that empty list. If you want 1 or more elements, though, we want to read an integer in and take that value and cons it onto a call to read list of len minus 1 elements. So we can see this in usage here. We can call read list, and we'll just say to read 5 values, print line, whoops, this returns something to us. We have to remember to store it off, give it a name so that we can do something with it, and then we can print that out. If we run this, it sits there and it waits until we give it some values. So how about 1, 2, 3, 4, 5? And we get the list 1, 2, 3, 4, 5, exactly as you would expect. Notice that lists print themselves out nicely. Arrays didn't, the lists do. Once again, that has to do with the fact that arrays are actually using the Java-based construct for efficiency. We could write our own print list. We don't really need to do so, though. Now the thing with arrays is because arrays it was not efficient to add elements to or take elements off of an array. Basically, when you had an array, you made it of a certain size and you could change the values that were inside of it, but you couldn't really change the length of the array. And this is one place where lists can be beneficial. Because this cons operator is efficient, we have the ability to write a different version of read list that does not take any arguments, we'll make it so it returns a list of int again. And the idea here is that this read list is going to keep reading until the user types in quit. So the first thing that we want to do here is to read a value from the user. Now, if the value they type in is quit, well, then we're done. There's nothing more to be added to the list, and we return nil. Otherwise, we're going to take that word, convert it to an int, and cons that onto the rest of what they type in. And so now, instead of calling read list here, we can type in read list until quit, and come over and run it. And now we can say 1, 2, 3, quit, and we get 1, 2, 3. If we say 7, 6, 5, 4, 3, 2, 1, quit, we get a larger list. So this gives us the flexibility of being able to enter values when we don't know how many we're going to want when we start off. Now, to help illustrate the use of head and tail, we'll do another one of these functions. It's very similar to what we did with arrays. I want to sum up the values in a list of integers. This should give us back an integer, which will be the sum of all the values. This is a recursive function. So we have to have a base case. And in this case, the base case is there's nothing left in the list. We could say that by list.length equals 0. There is also a method called isEmpty. So if the list is empty, there's nothing left to add up, and we give back a value of 0. Otherwise, we want to take the first element of the list and add it onto a recursive call with the tail. So whatever our list has that gets passed into here, this takes the first element and it adds it onto what we get with the call for everything that is left in the list. And this will repeat, repeat, repeat until we get down to a list that is empty, and then we return 0, and everything will be added back up. So we can come down here and print the sum list of LST, and if we run that, let's say 7, 5, 3, quit, gives us back the list 753, and it has a sum of 15. Now, at this point I want to write something that is a little bit more complex than what we have done so far. So first I want to write a function read names and ages. And this function is going to return to us a list. So the idea here is we are reading in the names and the ages for a bunch of people. And those names should be associated with the ages. So we're going to store these inside of tuples of string and int. Okay. And we want to make a list of those tuples. So every element of the list is a person's name followed by that person's age. And we're not specifying how many there are, so we are going to use the approach where we keep reading until they type in quit. So name equals readline. If name is quit, well then we're done. Just give back nil. Else Well, what do we do in the other case? If they typed in a name that wasn't Quit, we also need to read in an age. And we can call readInt to do that. And then we want to take the tuple of name and age and cons that onto read names and ages. The recursive call will read in more until they type in Quit. So let's make a new variable. We'll call it people. Read names and ages. And just to show that this works, we can print line people. Come over here and run this. Okay. That's our first list. So now we want to have some additional input. We type in a number of names here. Bob's 57, Jane is 45, Jim is 12, Ken is 27, and then Quit, and you see we get a list of those tuples, names and ages. There are a number of things that we could do with this. We could try to take the average of people's ages or whatnot. What I want to do is I want us to write a function that will, as the comment says, return the name of the youngest person. So the way this is going to work, def find youngest, this takes as input our list, and it is a list of string and int. Okay. And what it is going to return to us is the tuple, a string and an int, for the youngest person in the list. Now, how do we do this? What's the base case? Okay, when do we stop going? Now, for most of these operations, we've stopped going at, well, on the input for Quit. For summing, we stopped when the list was empty. That's a bit problematic here, because if the list gets down to being empty, we don't have anything to return. Okay, so that's a bit of a problem for us. So we kind of need to stop when there is only one person left in the list. And we can do that. We'll note this is not an efficient implementation, but it'll work for now. If list.length happens to be 1, then we are going to return list.head. Else. Well, if the list is not of length 1, and we're working on the assumption that it's larger here, then we need to compare the age of the person at the front of the list to the age of what we get back from the recursive call. So first we're actually going to do the recursive call. So we'll make a variable called youngest, and it will be equal to find youngest on lst.tail. Okay, so everyone except for the first person. Now we either want to return lst.head or youngest, depending upon which one is actually younger. So we can have an if lst.head _2. Now this is one of these places where we are pulling things out of a tuple. We're using the underscore methods here. There are other ways of doing this. In particular, pattern matching might be nice. But if they are less than or equal to youngest dot underscore 2, then we will return lst dot head. Let's go ahead and add it up here. Else, we'll return youngest. Print line, find youngest of people. We can come over here, run this. Bob, or Bib is 57, that's fine. We don't care. Jane is 45. Jim is 12. Ozzy is 99. And is 27. Quit. You'll see that it prints out our list, and at the end it tells us that Jim is 12. So it did manage to find the youngest. Just one last thing. I mentioned earlier that this was not an efficient way to find out if the list only had one element. And the reason that is the case is it turns out that asking for the length of a list has to go through all of the elements in the list. And so that's when the list is short, that's fine. But when the list is really long, this is going to be a slow thing to do. A slightly better way of doing this would be to say if the list tail is empty, then we return the head. So if there's only one element in the list, it has a head, but the tail is nil. Okay, so then the tail is empty. That would be a somewhat more efficient way of doing this. So that wraps up our coverage of list basics. We ran through the general idea. Lists are sequences just like arrays. They hold values. They hold them kind of in an order with a numeric index. There's the simple syntax for building them, where you put list and then give it all the values that you want inside of it. More often, you'll actually use these cons operators. Now, lists are immutable, so cons does not change an existing list. It builds a new list that has the additional element added to the front. And typically, though you can index things by value, typically we don't do that. Instead, we will generally use the methods for head and tail to pull off the first element and get everything except for the first element. And we can use that in a nice recursive method to run through things. So that's it for this video, and there will be more to cover basic methods that you can use on lists and arrays.